Hi Sola, here is the second page of your Unit 3 test. For question 3, you're asked to find the horizontal asymptote and then test to see how the curve is behaving near that asymptote. So the test will be very similar to what you did or what I showed you for question 2 in part A. What I'm going to ask you to do is go back and look at the content for this section. There is an example of how to test for the vertical and the horizontal asymptotes there. You're not finding the horizontal asymptotes or the vertical asymptotes correctly, and you need to go back over that section and practice those questions before you attempt the test. So looking at number 3, your horizontal asymptote, the way you find a horizontal asymptote is the first thing you do is you eliminate anything that's not significant. And so when we say it's not significant, what we're going to do here is we're going to let x approach infinity. If I let x approach infinity, then 1 is not a significant number because the value of 1 compared to infinity is negligent. So I'm going to get rid of that minus 1, and I'm just going to look at 2x squared over x squared. Now if I simplify 2x squared over x squared, the x squareds will cross out and I get 2. That tells me that the horizontal asymptote is y equals 2. Now you need to test your horizontal asymptote, and the way that you do that is you're going to find the limit of the original function at large and small values of x. A large value of x is 10, so you're going to sub in 10 and see whether you get a positive or a negative answer. If I sub 10 in here, I'm going to get 200 minus 1, so 199 over 100. That's 1.99 minus 2. That's actually just slightly on the negative side. That tells us that the curve is below that asymptote. If I do the same test for x equals minus 10, then I'm going to get the same answer because we're always squaring our x values. And so we know that the curve stays below the horizontal asymptote at all times, and that helps us to graph it. Now, if we look at question 1 here, I've also written in some information for you. You found the first derivative correctly. You set it equal to 0, and you found your extreme values, your critical points. You tested them in the second derivative, and that's correct. So you found a max and a min, and that's correct as well. For critical values, we also need to include POI, and that's mentioned in the question itself. A POI is a point of inflection. That's a point where the curve changes from concave down to concave up, or from concave up to concave down. So when we're looking for a point of inflection, we take the second derivative and we set it equal to 0, and I've done that for you over here. So there is a point of inflection which is also a critical point or a local extrema, and you need to include that in your answer. For question 2, you are supposed to find the equation of the oblique asymptote or slant asymptote, and then test to see how the curve is behaving near the asymptote. For this question, you're going to treat it very much like a horizontal asymptote. The test is exactly the same as a horizontal asymptote. The only difference is that for an oblique asymptote, the degree or the exponent of the numerator is higher than the degree of the exponent in the denominator. That's how we know that we have an oblique and not a horizontal asymptote. You'll have one and not the other. You can never have both. The way that we find it is we take the top, the numerator here, and we divide by the denominator here. And whatever we get without the remainder is the equation of our asymptote. So the OA is y equals negative 2x. And then you have to test it exactly the same way that we did with the horizontal asymptote. And I'm going to ask you to look at the content, course content for that so that the video doesn't become too long. Now for question 3, I can see that you've got a start to question 3, and I'm assuming that the rest of it is on the next page. You've found the derivative correctly. You found the second derivative correctly, so those are good. If you put y equal to 0, you're going to get the x-intercept. If you put x equal to 0, you're going to get the y-intercept. Those will be useful values or useful points for us to put on the graph for sure. The x-intercept, it looks pretty hard to find. You would have to factor that using factor theorem. So it may turn out that it's too hard and too difficult to actually find those values, especially if you're dealing with decimals. You may want to just give up there because it may not be worth it to find those points. I'll have to look at the second page or the third page of your assignment in order for us to finish this one off. So I'm going to end this video here, and then we'll look at the third page together.